All right, let's do a few more examples using synthetic division to find some polynomial divisions. So here we've got 3x cubed minus x squared plus 2x minus 3 divided by x minus 2. Let's set this up. We have the form here x minus k, the divisor, so the k is going to be 2. I'll write that down. All right, and now we list the coefficients in descending degree order. So we've got a cubic term, quadratic term, linear term, and then a constant. So we'll start with the 3, -1, 2, and -3. All right, and remember the procedure for synthetic division. The first step is to bring down the first term, so 3. We multiply by the number out here, in this case 2, so 2 times 3 is 6. And then we add, so -1 plus 6 is 5. Multiply, 2 times 5. Add, multiply, and then add. All right, the result here is the coefficient of the quotient, and this is the remainder term. So we have that 3x cubed minus x squared plus 2x minus 3 divided by x minus 2 is 3x squared plus 5x plus 12 plus 21 over x minus 2. All right. Let's do another example. Here we have 4x to the 4th minus 2x squared minus x plus 1 divided by x plus 2. All right, let's set up the synthetic division algorithm. So we have the k here, x plus 2, and this should be of the form x minus k. With the plus, we can think of this as minus a -2, so the k is actually -2. All right, and now we list the coefficients in descending degree order. So we've got a 4th power term, well, there's no x cubed term. We've got an x squared term, x to the 1st, and the constant term. So we have 4 for the x to the 4th term. There is no x cubed term, so we need a 0 there to keep that placeholder. So 4th power, 3rd power, 2nd power, -2, 1st power, -1, and constant, 1. So 4, 0, -2, -1, and 1. All right, and now we run through the procedure. So bring down the 4, multiply, add, multiply, add, multiply, add, and then multiply. So 29 times 2 is 58. Positive 58 because negative times negative. And then add. 59. All right, so this polynomial divided by x plus 2 is going to be 4x, 1 degree less, cubed, minus 8x squared, plus 14x, minus 29, plus 59 over divisor x plus 2. All right. This is the answer for this division. I said there's something interesting about this remainder term, and we can look at that by taking this polynomial and evaluating it at the k here, at -2. Let's just do that. Let's see what that is. So we've got 4x to the 4th. So we'll have negative 2 to the fourth minus 2 times negative 2 squared minus negative 2 plus 1. So again, we are evaluating this polynomial at the k value, negative 2. Right, let's see what we get here. So we have negative 2 raised to the fourth power, that's 16. So we have 4 times 16, positive 16 because negative 2 raised to an even power is going to be even. We have negative 2 squared, that's 4, times 2 is 8, minus 8, minus negative 2 is plus 2, plus 1. Okay, and then 4 times 16, well, I know 2 times 16 is 32, and then another 2 would be 64. So 64, and then I can combine all these. Let's see, we were at negative 8 plus 2 minus 1, so that's really 3. Negative 8 plus 3 is negative 5. What's 64 minus 5? 59. How about that? Same thing as our remainder. So as we'll see, the synthetic division algorithm not only gives us a quick way of dividing polynomials, but also evaluating polynomials for particular values. Whatever we want to evaluate the polynomial at, we'll plug it in, and the remainder will be the polynomial evaluated at that k value.